The video today is dedicated to Rachel. We miss Rachel. Chris is crying in the back of class, and we hope to see you soon. We'll dedicate the next one to Danny. How's that? And then to Nathan, and then to Taylor. All right. F composed of g of x is defined as f of g of x. As a matter of fact, f composed of g is the same thing as f of g of x. They mean the same thing. You will see both of them used within calculus. You'll see both of them used on the ACT. What is it that we do? We start with x and we plug it into g. Does anybody know what you get out when you plug x in? You get g of x. Awesome. That's amazing. What do you think we then do with g of x? We plug it into f. And when you plug it into f, you get out f of g of x. That is function composition. So we're going to go straight to the example. Given f of x is 2x minus 3 and g of x is x squared plus 2x, find f of g of 0. That means I take 0 and do what? Plug it in right there. And what do you get? So this becomes f of 0. Now I determine f of 0. What is f of 0? We're going to flip it. We're going to do g of f of 0. I plug in 0 to what? And I get negative 3. Then I plug negative 3 in for g, and I get negative 3 squared plus 2 times negative 3. This could be 9 minus 6 is 3. See that? Now, one point I'd like to make, and this is important when you speak of group theory, as we just talked about, is, for example, 5 times 3 is the same as 3 times 5. Would you agree? Is 5 minus 3 the same as 3 minus 5? Are those the same? No. And the reason why is you said that multiplication is what we call commutative when working with real numbers. Subtraction is not commutative when working with real numbers. It turns out that composition is not commutative. Meaning if you switch them around, you do not necessarily get the same thing. You understand that? What's different about letter C? Yeah, it's got the circle. It means the same stinking thing. You just plug the negative 2 in for G first. And when we plug in negative 2, what do you get? You get 4 minus 4, 0. What do we do with the 0? Plug in for F, and we get negative 3. For the next one, we take the negative 2 and we start by plugging it into F. 2 times negative 2 is negative 4, minus 3 is negative 7. So I now have G of negative 7. Negative 7 squared plus 2 times negative 7. So 49 minus 14 is 35. What's different about E? Yeah. So I take 1 and I plug it into F. When you take 1 and plug it into F, what do you get? Negative 1. So then you take that negative 1 and you plug it back into F again. Try F on your own. Okay. Dane, what did you just say? Too easy. Okay. So we will get a little bit more complex, but won't be that bad. I would say that what I just showed you is the most common question involving composition that you would see on the ACT. This is the second most common piece that you would see on the ACT, and it's letter G. What is different about this compared to the ones we looked at earlier? Very good. We have f of x is 2x minus 3, and we have g of x is x squared plus 2x. So the deal is I start by plugging x in for g. And when you plug in x for g, you simply get this guy right there, right? So what do you think I'd do with that thing in red? Yeah, I plug it in right over here. So instead of coming up with a value, I'm coming up with a function rule. I get 2 times x squared plus 2x minus 3. I'm going to write it without parentheses, 2x squared plus 4x minus 3. We all good? Not too bad, right? The difference is g of f of x. Now I take f, and I plug in for x right here, and for there. Sometimes you have to plug it into more than one spot. I get 2x minus 3, quantity squared, plus 2 times 2x minus 3. What do I get if I multiply out the 2x minus 3 squared? 4x squared minus 12x, because you have a negative 6x and negative 6x, plus 9 plus 4x minus 6. Or 4x squared minus 8x plus 3. See that? You all good? Let's skip I and J and flip to the back side, because you don't need I and J. You're too smart for that. Mine produced colors, yours did not. Sorry, sorry, sorry. Or maybe you brought some colored pencils and you could color it in for yourself. So it's always an option. I love this question. This is a question that I've created. It shows us a connection between yesterday's assignment and today's assignment. It says f plus g of 2, use the graph provided to evaluate that expression. What we learned yesterday is that f plus g of 2 is as simple as f of 2 plus g of 2. You simply evaluate each function at that domain value and then add them together. Looking at the graph, what is f of 2? Negative 2. And g of 2 is positive 2. Add them together, we get 0. G minus f of 0. G of 0 minus f of 0. What is g of 0? Looks like the red one is going to bring me to 2. And then f of 0, the blue one, is going to bring me to 0. So I get 2. F times g of negative 1. It'll be f of negative 1 times g of negative 1. They're both what? 1. 1 times 1 is 1. F divided by g of 0. That'll be f of 0 divided by g of 0. What's f of 0? 0. What's g of 0? 0 divided by 2 is 0. Then we get to the new ones. All of a sudden you see an operation that you haven't seen before. F composed of g of 1. That means f of g of 1. Careful as you go about this. g of 1. I find 1, I find g, it has a value of, so this turns into f of 3. Now I take 3 and plug it in for f, and I get -1. You try the next one on your own. G of f of -2. I got 2. Is that what you got? I would just be very careful. I almost made the same mistake again. I almost went down to this one. My mind thinks above and below. It's like I think F is the one on top, G is the one below, but you can see that they switch. So just be careful, okay? All right, take some more time, work through some problems. We got one last piece to get to, and we'll do that in about 8 minutes. You know, it's every year it's different. You try to think of something. Okay, here we go. So we're going to end with this. Find the composition of the following functions, identify their domain. So it says find f of g. Well, that means I take g and I plug it in here, right? Now, before I do that, I want you, because this is where we started today, right? Talking about domain. Look at how I try to bring it full circle. We really do try to think about what the heck we're doing. It may not look like it. Sometimes we suck at it, but that's just how it goes. All right? Willie's like, yes, you're very bad at your job. Yes, you should quit. All right, okay. Look at g of x, okay? I know that this domain is all real numbers, right? And I know that 2 over x, that domain is x can't be what? 0. Okay. Well, according to yesterday's lesson, we would have said that you can't plug in 0, that's the overlap, right? That's not the case here. You compose them, and we get 2 over 3 minus x. I can plug in 0, can I? But I can't plug in because that would produce 0, which was the eliminated factor in the first one. See that? You got to look at the inputs of G, and then you got to look at the outputs of G that would take away from the inputs of F. And don't think of it all like that, but just realize that this doesn't show up in our first part, does it? So you can't just look at the first part. You got to think of it all the way through. So look at it before you simplify. Skip back 2 pages, okay? 2 pages and go to this spot right here. I'll kind of end my point right here with you, okay? So we're going to do this letter G right here, and we're going to state the domain of these compositions. So we're going to do f of G, then we'll do G of F. So this tells me to take G and plug it into F. Now, as you look at that, what's the domain of x squared? All real numbers, right? What's the domain of the square root of x? Greater or equal to 0, okay? Now watch what happens as we compose these. We get x squared square root, right? Now, you can simplify that, can't you? What's the square root of x squared? X. However, that doesn't mean that that's what the graph looks like. And we have to still think about the domain. Start in the order in which you plugged it in. What was the domain of x squared? All real numbers. Now, when you square any number, it's going to produce a positive. Is there any way you're going to produce a negative? No, so you don't have to worry about taking the square root of a negative at all, right? It's not going to happen. So therefore, your domain is all real numbers. Interestingly enough, when I go to graph this, watch what happens. The calculator does not lie. Turn on, you stupid calculator. There you go. Okay. Why did it take 10 times? Okay. Look. I only get the positives because when you square something, it becomes positive. So see how this does not actually produce the, I mean, you can't just graph the line x, can you? Your range is all real numbers. So you have to consider it before you simplify it. Watch the next one. This is really cool. I take the square root of x, and what do I do to it? I square it. Now, in the same way, your output is x. But think about it. Square root of x, what can you plug in? Anything that's greater than or equal to 0, right? And then when you square that, you're still going to get a positive, but you're limited with what you can plug in here, aren't you? So your domain here is x greater than or equal to 0. You have to consider it before you simplify it. And you have to consider it in that order of operation. Watch what happens when I graph this guy. Same function. Look at that. It produces x, but only for values that are greater than or equal to 0, just like we determined. You see that? So that will take you through the rest of your worksheet. Good work today. You have 2 minutes left.